So, welcome guys to my another new video. So, in this video, I will discuss about one of the important concept of data structure and algorithm. That is one of the concept of sorting algorithm. That is selection sort. Okay. So, in this, like you will be questioning, but because like I didn't explain the bubble sort first, I'd go to directly to the selection sort. Why? Because uh, like bubble sort, like you can also do bubble sort in your, like you can also research about and understand the concept of bubble sort easily. Okay, but in case of selection sort, it will be a difficult one for you guys. Okay, so what bubble sort does is it compares the adjacent elements. Okay, in an array, suppose there is an array, it compares the adjacent elements and then it swap. Okay, so for every pass, so for a particular pass, okay, it will swap multiple times. Okay, so it takes more amount of time as compared to selection sort. Okay, and it also not recommended for when we work with huge data. Okay, so in this case selection sort, what is the advantage of selection sort is, so for a single pass what it does, it swap one time only. Okay, it does not swap multiple times, it swap one time only. And the motto of selection sort is, like from the unsorted array it will find the smallest element and place it to the correct position. You will see this is the unsorted part, and it detects the smallest element and place it to the correct position, means the first index. So now this will be sorted, and in case of selection sort this will be unsorted. Now unsorted array, this is the unsorted portion. Okay, so from this portion it will detect again the same steps will be repeated. It will detect the smallest item and it will place it to the correct position. Again 11 and 12 is sorted. Again from this unsorted position it will detect the smallest element and it will place it to the correct position. But there is a big disadvantage, okay, of selection sort. That is, if the array is sorted previously, it cannot detect. So see, after pass 3, in pass 4 the array is already sorted. Okay, but still it performs the same steps. Okay, so here from this unsorted part it will detect the smallest part. Okay, sorry, it will detect the smallest element. Okay, that is 25. Then it will swap. Okay, it will swap 25 with 25. Okay, then again it will repeat this step for 64 also. Okay, but though the array is already sorted. Okay, this is the main disadvantage of selection sort. That's why it is, like it is not good for using when we work with huge data, this part also. Okay, so what is a selection sort? It sort an array repeatedly by finding the smallest element, okay, from the unsorted portion. Okay, and placing it in the correct position. Okay, and the advantage I have told you, like these are the 3 points you need to read it. Okay, for understanding the implementation of selection sort. Now it is faster than bubble sort, as well as in a single pass it swaps one time only, not like bubble sort, like it in a single pass it will swap. Bubble sort, in case of bubble sort, in a single pass it will swap multiple times. Okay, but in case of bubble sort it swaps multiple times. Okay, and it is not good for huge data also. For like for huge data we will work with merge sort, heap sort. Okay, okay, that way don't need to worry about that. I will also give like upload videos about heap, merge sort, and also insertion sort also. Okay, don't need to worry about that. After this I will do all of that. Okay, so today we will understand the implementation of selection sort using Python. Though I'm telling Python has a built-in function called sort, like if we use that, it is automatically sort the array. Like though there is no array in case of Python, but we can using NumPy we can implement array. But I am using list only to show you the implementation. Okay, and in case of list, if we use the built-in sort function of in Python, then it will sort the list. Okay, but we will not use because it is not good for maintaining huge data. So that's why we use selection sort only here. Okay, and I will implement with the help of list only. So see, I've also, as you see in the binary search, in my previous video I have explained the binary search. As you see my approach, Okay, I have always maintained the concept of object oriented programming. I have used classes and objects. Okay, means instances. See, so this is my main block. Okay, so main function will be executed, and from the main function, okay, what I have implemented, I have taken an array, and the range of array I have taken as an user input. Then I have running a for loop that will append the number of list. Okay, and this for loop will run till the range, whatever the range the user input user will provide. Okay, and it will append the elements into the list. Then we are printing the unsorted array, whatever order the user provides, insert the elements into the array, that array will be, means that list will be printed. Okay, now I have taken the length of the array in size reference variable, and then what I have done, I have created an instance. Okay, sort operation. Okay, sort operation is my class name. I have created an instance. Okay, then what I have done, I have taken one another user input, that is I have to press 1 for seeing the for show, like for seeing the sorted array. Okay, if I press 1, then only this selection sort method which is present inside the class will be called, and then only the sorted array will be printed. Okay, so now let's see the selection sort method. Okay, this is the main, like this is the method where the main logic of selection sort is there. Okay, so now this is the for loop. Okay, for loop in this part, like this is the array. We have used two parameters, that is array and size, and in case of calling the method, I am passing two arguments, array and size. Okay, means this array and size will be passed as an argument, and that will be received by these two parameters which we have declared during the creation of the selection sort method. Okay, now I have run for loop till the size minus 1, means whatever the size, suppose there is 5, the size of 5. Okay, so it will run till 4. Okay, till range 4. Okay, now I am assigning the I value to the mean index. So now mean index is 0. At first mean index is 0. Okay, because I value is assigned to the mean index, so mean index will point to the first element, 0th index. Okay, this 64. Okay, now I have used nested for loop. In case of nested for loop, what is done, like the nested for loop will run from 1 to the size, till the size. Okay, the value of the size. Okay, that means 5. Okay, now I plus 1 means I is 0, 0 plus 1 means 1. Now j will point to index 1, means 25. Okay, now it will check, we have used if block, it will check if array of j means 25 is lesser than array of min index, is lesser than 64. 25 is lesser than 64. Yes, 25 is lesser than 64. Now j value will be assigned to mean index, means now j is pointing, now mean index means pointing to 25. Previously mean index is pointing to initially 0th index. Now 25 is lesser than 64. Now mean index will point to 25. Okay, now again j will be incremented. Now j will now point to 12. Okay, now again it will continue compare if array of j lesser than array of min index, means 12 is lesser than 25. Yes, 12 is lesser than 25. That means again min index will point to 12. Okay, and again j will be incremented, j will now point to 22. Okay, now it will again check if 22 lesser than 12. No, in that case no, then again j will be incremented. Now j will point to 11. If 11 is lesser than 12, yes, 11 is lesser than 12. Now mean index will point to 11. Now first pass is completed. Okay, you have didn't seen any type of swap. Now in first pass you will see the swap. Here you will see the condition, the for loop condition is false, then it will execute this line number 13. Now in case of line number 13, what is there, array of I will be replaced, like array of mean index, the array meaning this pointing to the index, that value will be replaced of array of I. Array of I is 0, means it is 0th index, means 11 is basically placed in index 0, means the first index, and this array of min index means whatever is there, like array of array of I, whatever 64 will be placed to the last index. Okay, it will swap. Okay, see, it will swap. Okay, so in the second step you will see 11 and 64 is swapped successfully. So the motto in every selection sort is to find the smallest element from the whole array and placed in a correct position. Okay, that's what they have done in the first pass. So you have seen in a single pass only swap will happen one time. Okay, in the second array again same step will be happen, again same step will be happen. So now in step 2 I will be incremented. Okay, so I will be 1 now. Okay, so now so I value will be assigned to mean index. So mean index now point to 25, means there are two parts. Okay, now that after first pass there are two parts. One is sorted part and another is sorted unsorted part. Okay, unsorted array. So we will find the smallest position, smallest element from the unsorted array and then place it to the correct position. Means in the second index. Now 11 is a sorted position. Okay, we will not touch that element. Okay, so now mean index will point to 25 now currently. Okay, after that j will be point to 12 because I plus 1. If I value is 1, then j value will be 2. It now j will point to 12. Now again it will check if 12 is lesser than 25. Yes, then it will point to 12. Mean index will point to 12 because j value will be assigned to mean index. Now again it will check. Now j will point to now 22. If 22 is lesser than 12, no. If 64 is lesser than 12, no. Then we have found the mean index, sorry, mean value, that is 12. Now 12 will be swapped with the I value, means I value is currently 1, means 12 will be swapped with 25. So in the next in the third step, see, 12 will be like the 12 is in a correct position. Okay, so now again this 11 and 12 is in sorted position and this is the unsorted array. So we will again find smallest element from the unsorted part, that is 22. Again we will check from that only. I will be incremented to 2. Okay, I will be incremented to 2 and then j will be pointing to part 3. Okay, okay, 3. Now it will check 22 is lesser than 25. Yes, 22 is lesser than 25. Then again it will swap because 64 is not lesser than 22. Okay, so 22 will reach to its correct destination, means placed in a correct position. Then again it will, now in after pass 3. Okay, you will see in a single pass only one time swap will be happening. Okay, after pass 3 you will see minorly the array sorted. Okay, but it cannot detect. Okay, selection sort, this is the main disadvantage I have told you. It cannot detect if the array is previously sorted. Okay, it cannot detect. What it will do from this unsorted part, it will again check for the, like, look for the minimum value, again swap from with that minimum value. Okay, so 25 is currently pointing. Okay, and the mean value is also 25 because 64 is not lesser than 25. So 25 is replaced using 20 by 25 only. Okay, so after that same step will be happen for 64 also. Then in step 6 we will get the sorted array. Okay, but we can get it in after pass 3 only. In the step 4 only we can get the sorted array. Okay, so this is the main disadvantage of selection sort. So I've tried to explain you the implementation of selection sort and also like what is the difference between bubble sort and selection sort. Okay, so see the bubble sort at on your own. So if you have any doubt and any question, you can know me in comments. And if you want that I make another video for bubble sort also, that also I can do. So please tell me in comments, then that also I will do. Okay, so for uh, from this video this much only. Okay, so in the next video I will try to explain more sorting algorithms. Okay, that is, there are many sorting algorithms, like in mod sort, heap sort, insertion sort, all of them is there. Okay, I will try to explain them. Okay, and also you will get the starting videos of like beginning like videos of Django project for the beginners also, and from code python also. Don't need to worry about that. Okay, so till then, bye bye.